Web performance is hard, but thankfully it's getting easier to optimize the performance of our website thanks to a set of new web APIs and best practices. Optimizing the performance of your web app will bring you more customers and even make them loyal. During this talk, we'll cover many performance techniques, and you'll be able to apply some of them on your existing code bases. So let's start from scratch, and I'm going to show you how I would build a mobile web app from the ground up in 2018. Are you ready?
Yes.
Yes, so let's get started. What I'm going to build is a mobile bank. What I'm going to build is a bank web app, and I got an inspiration from where I live. This is my real bank account, one of them, and this is a real native app, so I'm not affiliated with them. I just really, really, really love their native app. Take a look. You can do pretty much everything from the app. It has a great user experience. You can see your last payments, do split requests, pay, see your banks, everything's in real time, and the mobile app is just amazing. But of course it's amazing, it has great performance, it's a native app. So I thought to myself, can we do something that looks exactly the same with the same performance and user experience as a website, as a mobile web app? Is it going to be yes or no? Yes. So this is an experiment I made. It's a web app or also a progressive web app. There's not really a difference other than just adding it to the home screen here. And take a look. So you can also see the last payment I've done. You can pretty much go from tab to tab, and it's 2018, there has to be a dark mode just like in everything. And it just works really well. It's very performant. So I'm going to walk you through how I built this. First of all, I had to think about my target audience. Am I building this for users in which country, in which city? How will they use it? So my target audience are people on the go. You're basically biking in the Netherlands and you have to pay for yesterday's beers. It's not like you're on your desktop and you have Wi-Fi connection. So this came up, this created some kind of constraints to me, which is it's going to have to be a mobile web app because you're not on the desktop. It will work on the desktop, but the target audience is on a mobile, which means performance is very critical, and that's what all this talk is about. And also data usage, even though data usage, like particularly in the Netherlands, is not a big deal, but when you optimize for data usage, you're also optimizing for performance. So the first realization that you have to make, and the first one that I started with, is that JavaScript is costly. It's actually the most expensive asset that you're shipping. I had the same conversation yesterday in Copenhagen. I was talking about a certain library that weighs 90 kilobytes, and the person asked me, like, it's just 90 kilobytes of JavaScript, it's not a big deal. It's not only about downloading those 90 kilobytes, it's about also processing. Processing times on mobile are much slower than you think. We can kind of assume that most developers have these really nice devices, but you cannot assume that your users have these devices. So your users will most likely, it of course depends on the market, are most likely running a device that takes 10 times more time to process your JavaScript. And this is a realization we have to start with. And it really makes a big difference once you understand that JavaScript is costly. And when JavaScript is costly, it means this is going to be the statement that we're going to work throughout this whole talk or throughout the whole project. We kind of want to avoid JavaScript. I love JavaScript, don't get me wrong, but we want to avoid shipping JavaScript if we don't need it. So we will ship as little as possible, and we will only ship it when it's needed. And how can we do that? I would say the first start is to set a performance budget. You all work with teams, and having a performance budget will be a great way to distribute this responsibility across your team. So let's take a look. You can come up with your own performance budget, or you can use the one I used here, which is my goal is to get interactive in less than 5 seconds on fast 3G. But why did I say fast 3G, not 4G? Because if you're on the go, you have to assume people are on fast 3G. They will be on 4G, but then they will dip into 3G, maybe even to 2G. They might even go offline, they'll be back to 3G. They're not going to be on 4G all the time. So you have to assume they are on fast 3G if they are on the go. What does get interactive mean? It means not showing something on the page, it means actually being able to interact with it. So this gives responsibility to the whole team, and I really, really like this, because if you have someone from the marketing department that wants to add a plugin, and that plugin is simply a script tag, but that script tag is 1 megabyte of JavaScript, and it basically ruins your performance budget. You don't have to be the one arguing with the marketing department that this is not a good idea. You have the whole team backing you up based on numbers that if we add this plugin, it's going to break our performance budget. So that's why I really like this. So naturally, the earlier you have it, the better, because you make sure you're not exceeding your performance budget. Another benefit of this is that you can monitor it with every pull request. So you can blame features. This feature made us go above our performance budget. Or maybe doing that feature will probably make us go over our budget. It lets you revisit it, maybe rebuild it in a different way. Who's using Webpack? So, has anyone set a performance budget in Webpack? Yes, it's actually quite easy compared to Webpack stuff. You just add a performance object, and you decide if it's going to be an error or a warning, and then you say the maximum entry point size is going to be 49 kilobytes or 50 kilobytes. So that's going to error or give you a warning if you have an entry point that's bigger than 49 kilobytes. And you can do the same for asset size. If you have some local assets, you can make sure they're not over 100 kilobytes. One trick here is that you should only add this on production, not on development mode. And if it errors, you will get this kind of error saying 78 kilobytes exceeds your performance budget. If you had warning, you'll get a warning, and then you know you have to fix this. Now, let me walk you through the 3 stages of my users going through my app. There's 3 stages. The first one is the first page load experience. The first page load experience is the first time they will ever land on my website. So nothing in the cache, no service workers, nothing in the cache at all, 0. So it's really important. Let's take a look how the first page load experience looks like for this one. It's quite smooth, right? Let's see why. So who here has been on a date? Was the first impression important? No answer? Okay, let's have a talk after the talk. So the first impression is really, really important. And if you screw up the first impression, you pretty much don't get a second date. I mean a second visit. So make sure to have a very good first impression. And again, if you're building for mobile, take Fast3G as baseline. And don't forget that service workers are great, but in the first step, like in the first page load experience, you cannot have a service worker just yet. So you're loading just index.html, app.js, app.css. So I'm going to walk you through a page structure that I'm following here. It doesn't mean this one will work for all of the scenarios. It will work for a lot of them. And this one is really optimized for performance. So I'm sure you've all heard about it, but there's a twist. Who here heard about the App Shop? Yes, improving year after year. The App Shop is just a pattern we took from mobile apps. Now, I will show you how all of your native apps have an App Shop. It basically, you start by showing everything but the content. So just showing the structure of your app. If you had the navbar, you would show the navbar, maybe a background color, the cards. Here we're also showing that there's a sidebar, but you don't need to have a sidebar. And then only when your content loads, you just put the content inside the App Shop. Now, I told you this is a native app pattern. Can someone tell me an app that has an App Shop pattern, like a native one? Facebook? Gmail? Pretty much whatever you said is going to be true, so the question was kind of useless. So, look, native. inbox. This is the like a Gmail inbox. This is the app shell. We have a navbar, background color, also sidebar maybe, and the floating action button. Facebook. I don't know why you have stories. It's driving me crazy. Facebook. We also have a pattern. No personal information. See, this is just a generic app shell. I don't even have my picture loaded yet. I was even surprised to know that even the camera app has an app shell, because you have like a split of a second for the camera to load. This was a nightmare to get a screenshot. I had to take a video and then go frame by frame. But again, this is just a background color black, and then the nav bar, and then the buttons. Twitter as well. So our app shell is going to look like this. So I'm basically playing the same video. I'm going to play the same video as before and pause it before we load the content. So let's take a look. This is the app shell. So what do we have here? We have, of course, there's different colors, but the projector is not showing all of them. We have the background color. The background color is actually quite important, because if it's just white, it would show like the website is not loading yet. But as soon as you change background colors, you kind of prove to the user that I'm loading your page, I'm progressively loading it. What else do we have? We have the nav bar, we have the loader, we have the tab bar. Now, how do you implement the app shell pattern in HTML? It might look a little bit weird, but let's take a look. We start first with the head, of course, and then I'm going to include a script type module. Hands up if you've heard about type module. Cool, that's quite new. So script type module, and then I load the app.js, and then underneath it, I inline the app shell CSS. So actually inside of the HTML, which sounds like a bad practice, you inline the CSS, only the ones that you need to be able to render the app shell. In my case, I always go for CSS variables, because they allow me to do the dark theme much easier. I set the stuff on the body, navbar, tabs, screens, and that's pretty much it. And then I have the rest of my CSS. I could have like 200 kilobytes of CSS. Of course, I'm not going to put them here. And I cannot just do link rel style sheet, because that's going to block. That's going to make my page much slower. So instead, I'm going to do the link rel preload, which works, I think, on 70% of browsers. It's coming soon in, I think, Firefox in the next version or two. So link rel preload, the app.css, this is going to continue rendering the HTML, and in the background, load the CSS. And when it gets loaded, you swap the preload to style sheet. So this is the only, probably the easiest way to preload CSS and then set it as a style sheet. You also need the load CSS polyfill, because you need to support all browsers. But the load CSS polyfill is only 0.5 kilobytes, and I think that's not gzip, just minified. So it's quite small, which is good, so you can inline it. And then, because this is relying on JavaScript here, if you want to fall back to people with who have disabled browsers, who have disabled JavaScript, then you want to do a link rel style sheet. So that's like a fallback. Then after the head, you have the neck and the body. And in the HTML, you have the app shell HTML. So in the body, you just have the app shell HTML. This is going to be, some people do it in server-side rendering. If your app shell is static, you can just put all of the HTML for your app shell. And then afterwards, and this is quite important, this is what a lot of modern websites forget. This is where you have to also inline a piece of your JavaScript, not all of it. And I know this sounds really weird, but you'll see my point in a few slides. You only have to inline the part of your JavaScript that belongs to the app shell. Because if you show a tab bar and you cannot click on it, then this is really frustrating. So I'll show you an example of a real website. And then at the end, I still need to support all browsers. So I'm going to do a script, no module, and then load the legacy JavaScript. Now that was a lot. You don't have to do all of them. I'm trying to show you everything you can do, and then you can take some of the steps and apply it on your app. And then we close the body. So as a recap, this is everything we've done. I've omitted a lot of details, so this is not technically correct. But you see we have the script type module, the app shell CSS, etc. Now, what is this script type module I've been talking about? This is where you're taking a picture. That's it. But don't forget that there are some missing details. So what is this script type module we're talking about? It has really good browser support. That's 75%, because it's quite. It was also, I think, rolled out more or less at the same time by all browsers. Let's take a comparison of modern browsers now and old browsers and see what we're doing. Modern browsers support script type equals module, whereas older browsers, they don't know what it means, so they simply ignore it. So if you have a script type module in an old browser, it just doesn't run. But modern browsers, on purpose, will ignore the no module. So modern browsers will not load both if you have module and no module. They will ignore the no module on purpose. That's part of the spec. Whereas old browsers don't know what the attribute no module means, and it's just an attribute. So they will actually run the script that has no module because it's a regular script for them. And at the same time, modern browsers have ES 2015 Plus support, whereas old browsers only support ES 5. And this basically lets you do something really nice. It lets you ship ES 2015 Plus to modern browsers with script type module. And for older browsers, how do you fall back to this? You create a legacy file that this is where you transpile your ES 2015 code into ES 5. So any user that comes to your website will either load the legacy file or the modern file based on the browser that you're using. This is quite slick, but it's also new. So, I mean, I don't think a lot of websites are doing it, but I think you will see this a lot more in 2019. And one of the benefits of this is smaller JavaScript file size. That's not the only one though. I mean, all modern browsers have really good support of ES 2015. And they're quite fast at it, so we don't really need to transpile anymore. We only transpile for those old browsers. And old browsers will load a slightly bigger JavaScript file. Now, just as an example, this will not always be the same. This was the case for me. A 50 kilobyte app.js was transpiled into 65 kilobyte legacy. 15 kilobytes is not a big difference, but you will have multiple ones of one of these files, and at the end you're saving around 150 kilobytes of JavaScript, so that's quite good. Now, doing module no module builds is really tough if you want to do it yourself. I couldn't even get it to work, so don't even try. It's really, really hard in Webpack. But there is a plugin by Pratik that actually does it for you. It generates an ES5.js and an ES6.js files automatically, and even works with dynamic imports. And I've heard that this will most likely come to the next version of Preact CLI. So in a few, weeks, months, the next version of Preact CLI will automatically give you module, no module builds. So ES6 and ES5, both JavaScript files. Now, who thought it was weird to inline stuff in the HTML? Please, raise your hand. Only you? Of course, like this is a technique, but you should not overdo it. So you have to watch the size of your app shell. In my scenario, I decided that the app shell, HTML, and the CSS, and the JavaScript, so everything aligned together, and maybe some SVGs, if I had some really small SVGs I want to inline, should not exceed 50 kilobytes. And that all comes down back to my performance budget, but to specifically, I want the app shell to load in less than 1 second. So because all of these resources are blocking, anything inline is blocking, so they're quite important. I don't want to wait for more than 1 second on fast 3G. So how much headroom does this give me? We know fast 3G is 900 kilobytes a second, more or less, and has 40 milliseconds of latency. If you do the calculation, you end up with only 50 kilobytes. And please do take care of the latency. Most of the websites on the internet don't factor in latency, but latency is there on fast 3G. So if you remove latency, you can download like a megabyte in a second, but that's not the case. You can download around 50 kilobytes a second on fast 3G. Now, who thought it was weird to put the scripts in the app shell? Come on, let's be honest. Okay, so look, this is the Dutch immigration website, and if you reload the page, it loads quite fast. You see everything, you see the app shell, and you click on the menu, and it just doesn't work. And that's really frustrating. And why is this happening now? Of course, this website is probably using jQuery, and then on document ready, you set all the event listeners. But if it wasn't using jQuery, you just had to put 2 event listeners, one for the menu and one for the search bar. inline in your script, because this is really part of your app shell. You don't want to delay it at the end. So this is the importance of correct prioritization. Has anyone used Ponderphobia? So this is a very cool website. If you're at work and you want to show someone, like, you want to use the library and you want to see if it's worth it or not, so that's something you should consider. Like one example is using Axios. It's a great library, but most of the time you can just use fetch, which is in the browser. I know with fetch you have to do a couple of extra lines, but what I personally do is I wrap it in a class, and then you can do everything you want, and it becomes as easy as Axios. Now you can see that this library, or maybe Lodash, or whatever library, will take 141 milliseconds to download, this amount of time to parse, etc. So we've been doing priority-based loading, and the first thing we started with were the critical stuff, the most important ones, which was everything in the app shell, HTML, CSS, and JavaScript. And then afterwards, which one of these pages should we give more priority to? It's going to be the accounts, because this is the one that's open automatically. So then I have to load the main page accounts. And what about events, cards, PR, and together? These ones will be lazy loaded later on. Because if I open the page, I'm going to see the app shell, and then immediately I'm going to see the accounts, and then I can switch to another page. So we have to give second most priority to the accounts page. So let's take a look. After the app shell, this is what gets loaded. Let's do it one more time. Okay, now. After the app shell, we immediately load the accounts. Now, let's talk about fonts. I'm going to give you two ways to deal with fonts, because web fonts are really slow, and there's a lot of great articles and great resources how to deal with web fonts, but in my opinion, at the end of the day, they're just slow, and we can't really do anything about it. So I'm going to propose using system fonts or the new variable fonts. Let's start with system fonts. They are pretty much weightless, because system fonts is about using the font that exists already on your mobile device. They're local files. And of course, I don't mean Comic Sans. So this is Medium on iPhone and on Android. And on Android, it's using Roboto. On iOS, it's using San Francisco. They're both system fonts. They're both local to their operating system. One of the benefits is we're not loading anything from the network. Another benefit is it gives it more like a native experience, because users on iOS are used to San Francisco but are not used to Roboto, whereas users on Android are already used to Roboto. Now the question is there a nice and easy and fluffy way to use system fonts? No, maybe, there is. It just doesn't work on all browsers. It's just system-UI, which is really cool. But browser support is not the best for it. But you could still use it. Let me show you how. You could simply say font family system UI, and then you basically fall back to all other possibilities. This is one I copy-paste. Of course, you're not going to memorize it. Take a picture of the next slide. Wait, this one. If you want to see how they map out, even though you don't really care. Basically, font family, if you give it 3 fonts and the first one doesn't work, it's going to fall back into the second one, fall back into the third one, until at the end one of them will work. So theoretically, not theoretically, I mean most likely, if Blink Mac system font was activated, it most likely means your users are on Chrome Mac OS. Because I could manually install, say, Roboto, and then it will use my local Roboto, but normal users don't install fonts. Developers maybe install fonts, but I think web designers and designers are the people that install fonts the most. But regular users will just have whatever font you have on the OS. And in the worst case, then you load sans serif. If you still need to use web fonts, you can use this with web fonts. So you can do anything that has to do with the UI, system UI, so use system fonts. And like anything that has to do with your app, you can then use custom fonts. Now, this is really exciting. Who knows about variable fonts? How do you expect to have, what do you expect about browser support? Good or bad? It's quite good, man. Look, so variable fonts allow you to have a single font file to store a continuous range of designs. You know that if you go to Google Web Fonts or any font website, if you need to have the regular and the bold, that's 2 font files. You need to have the italic, that's 3 font files. If you don't include the italic and do italic yourself, That's not the real one. It's called a synthesized version that the browser tries to do its best to do the italic version, which is fine, but if you're a web designer, you'll probably not be able to sleep. So this is variable fonts, and Rust support is quite good for it, right? And let's see what it does. It lets you give a font weight. Traditionally, font weight is 100, 200, 300, all the way to 900, and also limited to which font weight you have already loaded. But with this one, you can have any font weight from 1 to 999. So 543 is a valid font weight because you have the font file definition, not just like the way they look. You have the definition and you can create on the front end, on your website, wherever you want. So if you give it 543, it's actually going to give you 543. Font stretch, you can give it any percentage number between a certain range. And font style, also any kind of degree. Of course, you're not going to be loading 18 files, but as an example, if you had 18 web font files, 288, they will all come down to one file of 84. Just to show you how many savings you get. Now, this is all theoretical. You all want to see a demo, I'm sure. So let's take a look at axis per axis. And this is a variable font. And you see over here, this is the weight. There is a number here. This is probably like 560 something. But you see, as I make it smaller, it actually gets smaller, like 1 pixel at a time, not just 100. So you can give it any value for weight. You can even give it different optical size. And this particular font has a feature with zeros where you can decide if they want to be striked down or not. So let's see. This is a 0, and then if you enable the 0 feature, it strikes it through. Not strike through, I mean, I don't even know what it's called. And different font files can have different features, and this basically lets you do all of these cool things right in the browser. Also take a look at vfonts if you want to see other font families. Some of them like even have a gravity, and the font will be affected by gravity. So that's really cool. Now, if you want to use web fonts right now, there aren't a lot of choices of web fonts, variable fonts. So you can go to vfonts. There are some of them, maybe 40 or 50, but you will not, I think, find the one you're looking for just yet. And Google Web Fonts doesn't have variable fonts, so I think this is something to look for in the next year. Now, if you really want to use variable fonts right now, you can still use it and support all browsers by using CSS add supports. So, and this is not a typo, it's a WDTH. If it doesn't support this one, so add supports not, then you can fall back, for example, to System UI or even to web fonts. Cool, so now let's talk about the second phase of our web app, and this is going to be the browsing experience. So the browsing experience is still the first time users arrive to our website, but then we show them a very good first impression. So now this is the dinner of the day. So now this is what happens on the first experience. So as an example here, let's take a look how you can easily go through multiple tabs, click on modals, open modals, even do dark mode or anything. So we started fast because we had a very good experience in the beginning, and we also want to remain fast. And I think the only way, like this is probably something that applies to probably everyone. The only way to do this is through code splitting. And the motivation behind code splitting is if you bundle all of your JavaScript in one file and give it to the user, you're going to choke their CPU. You're going to have like a huge amount of parse time. Your website will be really slow. Yes, it will be faster later on because you like loaded all of the JavaScript, but it takes like 10 seconds on mobile. This is a real trace from CNN.com. So I want to show you a real use case that's tied to business value, because at the end we're doing something that has a business value. Mover, or Uber's PWA, loads 3 scripts, vendor, main, app, and together these weigh less than 200 kilobytes. And it basically means you can request a ride in less than 200 kilobytes. And that's really important because what is the main value, or what is the core user journey or business value of Uber? It's just to make you request a ride. Can you share a trip on m.uber.com? Yes, but this is not part of the main user journey. This is why it gets lazy loaded. All of these other functionalities only get lazy loaded. What does it mean? It means they only load it when they're needed. So if you need to contact the driver, this chunk of JavaScript, this piece of JavaScript only gets loaded when you need it. And it's not a hard thing to do. Let me show you how you set it up. It basically doesn't require any setup in Webpack. I just like to be very specific with files, very clear with files, because if I'm working on an app and there's like 50 files, I need to know where does this file come from. So I added a chunk file name just to say .bundle.js. And this .bundle.js lets me know that this is not an entry point, this is a chunk. And the difference between that is the entry point, you define them in entry, in the Webpack config. And the chunks are anything you lazy load or dynamically import, which I'm going to show you in a few slides. So how do you do code splitting? It's as easy as using dynamic import. Notice the parentheses, they are important. When you import without the parentheses, it actually pulls all of the source of that file and puts it in this JavaScript file. So it makes your file bigger. When you use dynamic importing, it will only import your JavaScript through like an AJAX request only when the import code is called. So that's going to be in the browser. So, but first, let me tell you something. If you import like this, it will work, but unfortunately you will get a chunk ID. I don't even know why. You get 0, 1, 2, which is not very clear. Okay, what is 10.chunkhash.bundle? So that's why you have to give it like a comment, Webpack chunk name, help, and now you will have a help.chunkhash.bundle.js. So this really makes it easier once you're debugging performance or once you have DevTools network tab open to see is the help opening like loading when it should be. You'll have help.something rather than file.something. So that's exactly how you do code splitting. That's it. Of course, I'll go into more details. You can also do route-based code splitting. If you have multiple entry points, you do entry of index, entry of pay, entry of orders. If you have multiple pages that your website, your users will land on. Now, how did I use code splitting in this bank app? I did the dynamic import for the events, because the events is not something my users will see as soon as they open the page. But I only want to import it once everything else finishes. So I just do a dynamic import to events. So I give more priority to the accounts, and I remove the events from the main chunk, from the main JavaScript file, and I only load it once everything else has loaded. You can also do more advanced things. You can say, only when I click on the Together tab, then load the logout.js. So you don't have to load all the JavaScripts all the time. Just load it when you think you need it. You can even do way more advanced things. If you have a module that exports a default function or even exports another function, you can even kind of import them and call them through dynamic imports. There's also the concept of perceived performance, which is very important for user experience, which also means very important for performance. If I click on something, you have to tell the user, we got your action, we got your click, and we're working on it. So how do you do that? You respond to the user in less than 100 milliseconds. So let's take a look at this example. I will click on, it's quite fast, but there's a slowed down version. I click on an event, and it opens a modal. Do you see something in between? What is it? Explosion? We see the ripple. So let's take a look at the slowed down version. You see, this ripple gives comfort to your users. It sounds dramatic, but it really is true, because it proves to them that this click actually worked. How many times do you have to click multiple times on a certain website and you're not sure if it's working or not? And it also gives you more headroom, because you showed I forgot the name, the ripple. You show the ripple, and then you have more time to work on the modal to make it open. So what I want to show you here is really important. It's so nice to have the ripple, but it's not critical. And because it's not critical, of course, dynamically import it. Don't increase the size of your JavaScript by just doing irregular import, because you're making all of your users wait more to show them a ripple. But why not, if someone was on a very slow connection, not show them the ripple, but at least show them the modal, because the modal has more important. So it's all about code prioritization and not including everything in one file. Right, now for the exciting part, web workers. Who knows about web workers? A lot of you, of course. What do you think about browser support for web workers? You're right, of course. So your JavaScript and the UI, your user interface, all run on the main thread. And if you have, so this is going to be an if, I'm not going to tell you all to go use web workers. If you have something that's very heavy that runs on the main thread, it's going to make your application really slow. Like even if you have a GIF, the GIF will stop rendering. Like it will freeze on a certain frame. So browser support is very good, really good. And so I think web workers are all about use cases. And I'm going to show you a couple of use cases. Let's say you have a background check when your app is running. So every 10 seconds you do a certain background check. This is something that can be offloaded off the main thread. Another example, you have heavy data processing. For some reason you have to fetch a file of 5 megabytes of JSON and you have to do some calculation on it. Don't do it on the main thread. Another example, every 10 seconds, let's say you call a weather system, and if they tell you it's raining, then you need to update the user interface. So you only update the user interface on a certain scenario, and you're doing check every 10 seconds, 20 seconds. So for these use cases, and of course plenty others, you can use web workers. In my example, I have a slow algorithm that encrypts my data before I send it to the API. And I want to avoid running this on the main thread. Kind of like a bcrypt that you have in backend frameworks that takes a second to give you the hash. So it's quite easy to set up with Webpack. You need to npm install worker loader, and then you say all the files that end with .worker.js will be passed to worker loader. And worker loader will kind of give you a class. That's really cool. Let me show you. So I create a new keys.worker.js. The .worker.js helps you remember that this is a web worker. No direct DOM access and no window, document, local storage. It's just going to be self, fetch, and other stuff. So I fetch the keys that I need in order to encrypt my data. I convert it to JSON, I get the keys, and I call generate token, and assume this function takes a while. Assume like it takes a second. And what I can do then when I get the result, so all of this is happening off the main thread, I simply send it back to the main thread with the self.post message, JSON object result, colon result. This does all the calculation off the main thread, takes the result, sends it back to the main thread. Now, the code of the index.js or of your main thread is actually much simpler than you think. You simply import it. You import the worker as if it was a class. So that's worker loader doing all of the stuff. You create a new version, a new instance of it, because you can call it multiple times. And then you listen on the onMessage event. When you get the message, then you can do whatever you want. Again, web workers think about use cases, something that's slowing down your device, but it's something that's slowing down your UI. And if you want to visualize it, you can see this is the performance tab, and this is the worker. I've actually moved 19 milliseconds off the main thread. This may not be too much, but 19 milliseconds will guarantee that you skip a frame. So if you're running this every 10 seconds, that's kind of a good deal that we've done. We've moved it out of the main thread. And the third section is about subsequent visits. And I wish I could talk more about this, but I only have 3 slides because I don't want to turn this into progressive web app slides. But if you've done everything, then it becomes as easy as just adding a service worker. But let me show you. Let's reload it. Okay. So if I reload the page, it just loads instantly. So let's see it one more time. Okay, reload the page, loads instantly. It even works offline. So I'm actually in airplane mode. And all of this is by adding a service worker. I'm not going to go a lot into the details. Feel free to come to me after the talk and ask me questions about it. But if you're using Webpack, you can use generate SW that just generates a service worker based on all the files that gets emitted through Webpack. Or you can have more control and use inject manifest, which will keep you in control of your service worker and also do the pre-caching for you. Now I have, I think, 5 more minutes, and I'm going to end with 2 things. One of them is leveraging modern web APIs. So the web has changed a lot. I had one of my students yesterday come up with a presentation and say, we need a mobile app because we need to access the camera. This is what we cannot access the camera on the web. This is what people think of the web. but you have to think that this actually changed a lot. So always ask yourself, can the web do that? Because you don't always need a library. A lot of stuff are included in the browser nowadays. And don't load polyfills on all browsers. I was trying to also show my students yesterday that fetch is a native function. So I opened GitHub and I opened another page and I write fetch and it doesn't show me native code. Because all of these websites were just polyfilling fetch. But we all have fetch except some browsers. So use conditional polyfills to support all the browsers. Don't ship the polyfills all the time. And you can do that easily with polyfill.io. So with this link, I request intersection observer, which works on Chrome and Firefox. So if you open this, it will give you almost nothing in Chrome and Firefox. If you open the same link in Safari, it will give you all of the code that you need to polyfill intersection observer. So you're rewarding users on modern browsers, not making them pay for something they don't need. And again, coming to the fetch API, you probably don't really need the library on top of it. You can just write your own class, and then you can do all sorts of cool things. If you're working with JSON, just default to JSON all the time, handle errors, add default headers, authorization headers, and even request and response interceptors. And who's using babel-preset-env? A lot of us. Just be careful of this. All credits goes to Jamie Builds. If you have just last two versions, this is actually quite dangerous. It basically means you're not using preset-env, because if you have this last two versions and you run it through a browser list will tell you what it's going to match. So what is last two versions going to match? IE Mobile 10 and 11. Like browsers that have 0% usage, which means last two versions will match these browsers forever, because IE Mobile 10 and 11 are the last two versions of IE Mobile and 10, IE Mobile. There will be no newer versions, which means they will match these browsers forever. So the recommended fix obviously depends on your target market and your browser support policy, but if you want something that works almost everywhere, just to a bigger than 0.3%. You can of course adjust. Not IE 11 unless you have supported, and not Opera Mini O. You can even localize it. So this will localize it to the Netherlands. You can do NO for Norway. And let's take a look. Now you have just these browsers. I think, I'm not sure, maybe not, okay, not all of them have ES6 support, but in a few months, if these numbers go down, then you will not be transpiling var, let, and const down to var. And finally, I'm going to end with debugging performance. So these are real tips from when I work on performance projects. Most of my projects are improving performance for companies. And it really all comes down to testing on real mobile devices and on all browsers. When I was building this, I opened it on Safari, and I clicked on another tab, scrolled down, and it just scrolled to the left, something really weird. And I thought this is probably something wrong with Safari, but of course I was wrong. I fixed it. It turned out there was a mess in the HTML. When I fixed it, not only it worked on Safari, it actually became faster on Chrome and Firefox, because I was hacking things around. So test on all browsers. Testing on Safari will actually give you better performance on mobile, better predictability on mobile Safari. And Lighthouse, who's using Lighthouse? Every step of the way, really, it gives you, it's like having this brilliant, smartest person on your team that just automated, and it's free, doesn't need lunch breaks. And also use the user timing API. This one is really cool. It allows you to create specific timestamps that are part of the browser's performance timeline. So I was helping a company figure out why a certain function is taking 5 seconds. And we were actually able to use performance.one. Let's say this is theoretically a slow function. You mark the start of it, you mark the end of it. You can call these whatever you want. And then after this function is called, you measure, so string duration time total, you do the start and the end. And not only this will give you a number programmatically that you can send to Google Analytics, you can also visualize it in the performance tab, which is brilliant here, duration time total. So this function is taking 174 milliseconds. Warning, there's something wrong here. And that's how we were able to pinpoint what's going wrong. And if you use React or Vue, you either automatically or maybe need to opt into it. You get user timing for the framework parts of it. So This is the React tree, this is the app container. So this also lets you know if, like which part of your applications were slow and if they were due to some parts of the framework. And the performance tab here as well, if you record the performance, like a recording, do a performance recording, you will have those bars, and always look for the big bars and try to drill down until you find your function names. If you find one of the functions you define and it's taking a lot of time, it means this function is slow, or this function is doing something weird. Or maybe it's being called 90 times instead of 1 time. So that was all for today. Please feel free to reach out to me, and you can follow me on Twitter and check out my website. Thanks.